Hello friends, welcome and happy new year 2026. In today's video we shall be discussing out of the two methods, the Codal method and UPBD method, which method is superior. In the arena of performance based design, UPBD method was superior to the direct displacement based design method because UPBD method could take two parameters within the design philosophy. However, now we want to compare entirely two different platforms, the Codal building and the UPBD building. Which method is superior? Now one item for comparison is very easy, cost. If one is less costly than the other, then this is superior certainly. However, there are more intricate and more in-depth parameters involved in the engineering solutions which should be taken, and the comparison should be made with respect to those parameters for these two methods of design. With this brief introduction, let us go inside the video. Today's video is on UPBD method and the Codal method, which is superior we want to establish. For this purpose, certain parameters to be considered which are to be compared. So these parameters are damage index. The damage index pertains to whole building or to a particular member as shown here, or some other elements. Fragility curves gives you the probability of accidents of damage and certain engineering parameter on the x-axis like spectral acceleration, peak ground acceleration, etc. So this is another method of comparing the superiority of one type of building over the other, and the cost. Obviously, if the cost is less, certainly the building is better. So we shall study all these parameters one by one. Each parameter will require one video. So we shall be discussing only damage index in today's video. Damage index quantification in a way is given in IS 1893-2025 part 1 in the definition of quantifying like this: single or few, when it is said about 5% buildings are damaged in the earthquake, when many, about 50% damage is there, 50% buildings are damaged, and most means about 75% buildings are damaged. Classification of damage of buildings are like this: grade 1 damage, slight damage, fine cracks in plaster, fall of small pieces of plaster; grade 2 moderate damage, small cracks in walls, fall of large pieces of plaster, particles slip off, cracks in chimneys, parts or chimneys fall; grade 2 moderate damage, small cracks in walls, fall of larger pieces of plasters, pantiles slip off, cracks in chimneys, parts or chimney fall; grade 3 heavy damage, large and deep cracks in walls, fall of chimneys; grade 4 destruction, gaps in walls, parts of buildings may collapse, separate parts of buildings lose their cohesion and inner walls collapse; grade 5 total damage, total collapse of the building. So you see, these are all qualitative damage descriptions which may not serve our purpose. Similarly, in the intensity scale of the code, certain damage scales are given up to 1 to 6 scale. These are the talking about the earthquake, whether noticeable, whether awakening and frightening, those things. From 7 to 11, it is damage. So 7 is damage of buildings, 8 is destruction of buildings, 9 is the general damage of buildings, 10 is general construction of buildings, 11 is destruction, and 12 is landscape change. Now let us see the definition of damage index. Structural damage index, DI, is a quantitative dimensionless measure, usually varying from 0.0 to 1.0, that represents the extent of damage sustained by structural member on or the entire structure under some loading, typically seismic loading. So damage index is 0 when no damage, system is elastic. Damage index is equal to 1.0, full damage, plastic. Now why damage index is required actually? The purposes are like this: to quantify damage, not just strength accidents, in probability of accidents of the strength; to relate analysis results with physical damage. So from the software you get the analysis results with the physically how we correlate; to support PBSD frameworks, that is those LS, CP, etc. limit states we have defined, how to define those; to assess residual capacity and repairability; to compare alternative design objectively. That is what we are studying here, the last one. Codal method is one method of design and UPBD method is another method. So we can compare through damage index which method is better. Damage index at different structural levels are like this. At the material level, we have cracking, yielding, spalling. At the member level, we have flexural hinge, shear hinge, axial hinge, and damage. At the story level, we have story drift, soft story formation. At the structural level, we have global performance states, collapse, LS, IO, CP, etc. Damage index and performance levels are correlated in this way. General, not very strict correlation, 0 to 0.1 negligible damage, operational level of performance. 0.1 to 0.3 minor cracking, immediate occupancy performance. 0.3 to 0.6 repairable damage, life safety performance, life is not threatened here. 0.6 to 1.0 severe damage, collapse prevention level, and greater than or equal to 0 failure or collapse. In certain damage indices may give a value slightly more than 1. Certain damage indices will give only up to 1. Basis of damage index. On the basis of damage index, we can have deformation based damage index, ductility based damage index, drift based damage index, dissipated energy based damage index, stiffness degradation based damage index, and deformation energy based damage index. Deformation based damage index is like this: deformation demand divided by deformation capacity. Demand is imposed on the structure by the earthquake or the loading, and capacity is from the sectional you have provided. Energy based damage index, energy demand divided by energy capacity. The earthquake will also impose energy demand, displacement demand, strain demand, and curvature demand, etc. And there will be corresponding capacity. Stiffness degradation based damage index is very nice. Di equal to 1 minus k second by ki. K second is second stiffness, ki is the initial stiffness. Let us understand this through a picture. So this picture is a force deformation picture between force and deformation. A red curve is the response curve of the force and deformation. If you draw a tangent at the initial point, you get the initial tangent, and the slope of that tangent gives you the initial stiffness, because at any point if you drop the point in the horizontal axis and vertical axis, you get force by deformation, which is stiffness, and this is nothing but also tan theta of the angle. So this is the initial stiffness Ki. Now we have considered 2 points on the curve. One is at less damage, this yellow one, where the stiffness is adding the origin to the damage point. This is called the second stiffness, K second 1. Second point has more damage because it is on the further away in the curve, and its second stiffness is K second 2. Obviously, this angle is larger than this angle, so K second 2 will be lesser than K second 1. Now say we take K second equal to Ki, then what you get? 1 minus 1, 0. So it is elastic condition, no damage. If I put K second equal to K second 1, then I get some value of the second stiffness divided by initial stiffness. This will be less than 1. So 1 minus this you will get the damage index to certain value. When you put K second 2 here, which is still smaller, you get this ratio still smaller, and so 1 minus this will be larger. So more damage index, more damage. So that is the meaning of this stiffness degradation based damage index. Now we have interstory drift based damage index. Damage index is equal to maximum drift divided by ultimate drift. So drift, as we discussed earlier in videos, can be expressed in ratio or in angle, radian. So interstory drift is given by or sway in the upper story minus sway in the lower story divided by height of the story. This comes as a ratio, and this can be expressed in angle also. That is what has been done here. Maximum angle divided by ultimate angle of expressed in the drift. So theta max, theta ultimate, how to get, we shall see later. Ductility based damage index, mu demand minus 1, mu ultimate minus 1. Mu demand equal to demand ductility or ductility demand given by delta max by delta y. Maximum displacement by yield displacement. Mu ultimate is ultimate displacement by yield displacement. So we can calculate this and get the damage index through ductility based damage. So this parameter, as I said, like this. However, the ductility can be expressed in terms of displacement, rotation, strain, or curvature. So these are all given here. We have discussed this in earlier video also. These are not different ductilities for the same system or same element. It is the same ductility expressed in different way. However, the magnitudes are different. This magnitude is highest, then lower, and lowest is displacement ductility value. Park and Yang damage index given in 1985 is very popular. It is given as deformation cum energy based damage index. This is the deformation part, this is the energy part. Delta max by delta ultimate divided by beta divided by Vy delta ultimate into integration dE. So here delta max is maximum deformation, delta ultimate is ultimate deformation. The distinction between these two we shall see in the next slides. Beta is the model constant, integration d is the cumulative hysteretic energy obtained in the time history analysis, and By equal to yield based shear or yield based force or yield moment. So see here, from hysteretic loop of the time history analysis you get this delta maximum deformation. Whatever loops is the largest loop, that will give the largest deformation. And delta ultimate you get from the pushover analysis at the breakage point, at the collapse point. Modified Park and Yang Kunnath et al. Given in 1992 is also very popular. Damage index is now given by theta max. It is again rotation. Minus theta r divided by theta ultimate minus theta r plus the previous part, which is the energy part. Here new term delta r is recoverable or yield rotation on unloading. So you can take for all purposes it is equal to yield rotation. So these are the angular rotation in the joint, and this is the energy in the loop. Through this you calculate the modified Park and Yang index. Now story damage index and global damage index are two parameters. Story damage index is summation of the damage index of a member and its corresponding energy divided by summation of the energy of all members. This gives you story damage index. Nm is the number of members in a particular story. Similarly, global damage index equal to summation of damage index of story multiplied by energy of the story divided by summation of the energy of the stories, and it varies from j equal to 1 to number of story ns. So this gives global damage index for the entire building. Now let us practically understand this damage index business and this calculation and the practical evaluation. So first we carry out the pushover plot. In the pushover plot actually it comes as a curve, but it can be bilinearized through the software. So we have shown here a bilinear curve. This is the breakage point or ultimate point in the curve, and corresponding rotation, the horizontal axis is rotation, the joint rotation, vertical axis is frame moment. So this delta u is the maximum ultimate, not maximum, ultimate rotation obtained from pushover analysis. Similarly, you take the loops in the time history analysis. Those are also coming as curved loops, but can be bilinearized like this. And maximum loop you take and maximum deformation is here, rotation is theta max. So this is how we get the theta u and theta max to calculate the damage index, and the energy is nothing but the area of the largest loop in the deformed this hysteresis loop, area of the largest loop, that gives the energy. So this is the way inside we calculate, and after you calculate, if you plot, you can get it like this. On the horizontal axis we have taken the maximum story level damage index, and the vertical axis we have given the stories. So maximum damage is on the ground story, then next story, etc. goes. And two bar diagrams you see, this is for C for Codal building, HEST ones, and U for UPBD buildings. You see the damage index for UPBD buildings is less. This I have taken from the thesis of my student. We shall discuss further on all this. So here through the damage index we see that the Codal buildings have more damage than the UPBD buildings. However, we shall make more discussion on this in the coming videos when we cover all the three items: damage index, fragility and cost. For further reading, you can see the PhD thesis of Pritam Haith, Structural Damage Assessment Models and Prediction of Global Damage Index of Reinforced Concrete Buildings using Artificial Neural Network. Here you will get at least 1000 references, and this thesis should be visible in the website of NIT Silchar. Then there are certain papers I have given here, you can read. Thank you very much for coming with me up to here. I think you have enjoyed the video. This video, as explained, a new term, damage index, which is extensively used in the researches and for understanding the extent of damage in a building under a particular earthquake, and it can be also used for comparing the performance of two series of buildings. Please subscribe the channel. It is a new channel. Subscribe the channel, like, share, and view the videos, and put your comments and queries in the comment box. I shall be glad to answer those. Thank you.